last part of elements. Elements.
Yes, indeed. Yeah, like 1 a.m. I couldn't sleep, so I just did all the stats. It's all the same answer. No, but like, I'm not. I don't actually. Yeah, I did it. Yeah, and then I watched. Okay.
All right. So f of x. So yes, last week we talked about how do you find horizontal asymptote. So horizontal asymptote. You know, this is a big part on AP exam. They love horizontal asymptotes. And I think in BC is very important as well. So horizontal asymptote is basically limits as x approach infinity of f of x equal to L and limits x approach to negative infinity of f of x is equal to L. So there are two types of L here that you can have two horizontal asymptote. I don't, yeah, there's no way you can have more than two horizontal asymptote. At least I don't think so. So and like a lot of things like you guys probably think, did I talk about like horizontal line? Did I talk about parallel line can intersect?
Like a sphere? Like
I didn't know for a long time, right? I didn't know as a math person, like I usually like watch math video for fun. Um, so I was reading through somebody like they say 1700, like there was a Russian professor, mathematician, and he says, oh yeah, um, the parallel line can intersect, and everybody thought he's crazy. Like I don't know why you call yourself a mathematician. So end up he was right. Like they are proving to right. German mathematician, another German mathematician say the same thing, and the Euler say the similar thing. Become a non-Euclid geometry. It's called projection geometry. I didn't know this until like recently. So don't ever take my word as lock. Like it's just true. Like you know how people tell you it's like anything to the zero power is one, but they don't explain to you why anything to the zero power is one. Um, so if I don't do that job, then that means I'm a bad teacher to explain to you what it is. And but you don't be just fixated to that concept is what I say is true, because a lot of time what I say, like I know Anthony want to challenge me a lot of time, Jared want to challenge me all the time. I actually appreciate those things because they want to challenge the status quo. In order for any improvement in any level of knowledge, is always people challenge the current knowledge, right? And they can exceed it and better at it. So something like this, I think like I don't want to say, so I don't want to say something that's for sure, but at least as far as I know, I think you cannot have more than two horizontal asymptotes. Maybe there's other situation one day you can come up with, yeah, you can have third horizontal asymptote. I don't know, but which it doesn't make sense. But in this particular case, but I'm just trying to say is always trying to think something that's different. Don't be what I say or what your professor say and be fixated on the knowledge. Try to think above it too, right? Can it be possible? Okay, so don't just say what I say is true. And this case, I don't think it's very hard to prove false, but um, so in here we're gonna approach that. So we talk about what if they are last week we talked about what is the horizontal asymptote in this case, right? And when Jing was here, I don't know where Jing is today. And where's the horizontal asymptote? 3/2. And how do we get 3/2? you divide it by highest degree. So you take this and you approach to infinity, right? So it'll be 3x squared minus 2x minus 5, and then 2x squared plus 5x plus 1. And you divide it by highest degree, so it's going to be x squared, x squared, x squared, x squared, x squared, x squared. Now you reach the same thing, limit x approaching infinity of 3 minus 2 over x minus 5 over x squared over 2 plus 5 over x plus 1 over x squared. So this is a plus, sorry. So ideally that you can do this. This part is going to go to 0. 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 It's not because your teacher says if they are the same degree, then just take the coefficient. This is the reason why you get it. On your pre-cal, they probably talk about same degree, then you just take the coefficients in front. But this is why that this is. Now, what if you have a numerator's higher degree? Let's just say if you have, in this case, this one's just going to be 3 over 2. That's going to be horizontal asymptote. Now, does it matter if I reach negative infinity in this particular case? Because 2 over negative infinity is still 0. 5 over negative infinity is still equal to 0. So everything is still turning to 0 except the constant. So that's why limit x approaching negative infinity doesn't really matter. Now, in other situations, does matter. So we're going to talk about those situations. Now, let's talk about power over polynomial again. So what happens if limit x approaching infinity of 3x cubed plus 2x squared over 4x squared minus 5x?
It goes to infinity.
It goes to infinity. Why?
Because you do the highest degree of the denominator.
And this is why we choose highest degree of denominator, right? We don't choose highest degree of numerator. We choose highest degree of denominator. And if you do this, this one's going to be limits x approaching infinity of 3x minus 2 over 4 minus 5 over x. We know this is going to go to 0. We know this is going to go to infinity. Infinity subtract 2 doesn't really matter. Divided by 4 doesn't really matter. This is still going to go to infinite. So in this particular case of 3x cubed plus 2x squared over 4x squared minus 5x does not have horizontal asymptote. Does that make sense? It does not have. And that's why your teacher says if a numerator has a higher degree, you don't have horizontal asymptote. What if a denominator has higher degrees? Then it's 0. But you can see that y is 0 now. What if I have 3x squared over 4x to the cube plus 2x squared? Right? Does it have a horizontal asymptote? Well, we can divide it by x to the cube this time. If I divide it by x cubed, then there will be a limit x approach infinity of 3 over x over 4 plus 2 over x. Now this part is 0, this part is 0, but it's going to be 0 over 4, so horizontal asymptote is at y equal to 0. So you get 3 situations. You got y equal to 0, or y equal to the coefficients, or does not have horizontal asymptote. Now last year we were talking about whether horizontal asymptote is truly gay or like or bi or like, you know, whatever. So so when did that situation occur? Right. A lot of you guys know like horizontal asymptote cannot be reached, cannot be crossed. Like you think about asymptotes of words that your function cannot cross that part. But that's not entirely true. Especially for Raphael, Krisha, Prakash, no, your name, something Khrushchev. Okay, Khrushchev. I always confuse this Indian kid with the fat Indian kid, not fat Indian, chubby Indian kid.
No, that's great. Dang, I'm
Choppy Indian kid. Sorry, I'm taking the fat back. Sorry.
Yeah, that's what
I'm such a horrible person. No, I wasn't trying to be horrible. It was just come out of my mind. I didn't. It did not process through my brain. Yeah. So what happened if you have this case? Let's say 3x minus 2 over 2x squared plus 1. A limit as x approach to infinity. Well, let's say we want to find out this horizontal asymptote. Right? I want to find the horizontal asymptote of this one. Now, what's the highest degree on denominator here, Raphael? What do you think the highest degree here on denominator? It's 1. Good. It is 1. But if it's inside a radical, it's square, right? Does that make sense? Because it's inside a radical, right? But I hear it's 1 because we are talking about inside a radical. If it's inside a radical, that's going to give you that. So therefore, limits as x approach infinity, that's equal to 3 minus 2 over x, square root of 2 plus 1 over x squared. And this part is going to go 0. This part is going to go 0. It's going to be 3 over root 2. Now, this is where you have a 2 horizontal asymptote, right? So limit x approach to negative infinity. And that's going to be 3x minus 2 over square root of 2x squared plus 1. And you're going to reach negative infinity. But before I talk about this, I want to ask you. I think you guys saw it, but absolute value of x, right, is this graph, right? Is there any other way to generate the same graph? Piecewise, what else? Besides piecewise, is any other way to generate the same graph? So piecewise, you can say, oh yeah, I can do piecewise, just do function x when x greater than 0 and the negative x when x is less than 0, right? That's going to be piecewise. But is any other function can represent the same graph? Yes. Square root of x squared, yeah. Do you see that square root of x squared is also the same thing? I mean, some of you guys probably saw it earlier, but root x squared is absolute value x. So on the left side, it's going to be a negative x. Okay, on the right side is a positive x. So when you approach negative infinity, something kind of changed. So therefore, it's going to be limits as x approaching negative infinity. That's going to be 3x over x, right, minus 2 over x. And now here is going to be 2x squared plus 1. It's over x squared, but it's on the left. It's negative. It's going to cause this whole thing to be negative.
Why?
Because on the left side, you're approaching left side, it's going to give you a negative x. So I'm going to put a negative sign outside. And in this case, it's going to be 3 minus 2 over x when limits x approaching infinity. And that's going to be 2 plus 1 over x squared. Now, this is a negative. So we're going to go approaching negative infinity. So this will end up being negative version of this. So that's going to give you 3 over negative 2. Oh, sorry, 3 over negative root 2. So there was 2 horizontal asymptotes. Now, a lot of time we thought like there are no like vertical asymptote. Vertical asymptote is like you cannot reach. Like we know that this kid is gay. Like for sure. Like, there is no way he can be anything else. Am I looking at you? What? Chase? Who's Chase's class?
Oh no.
I don't know who that is.
Chase Marshall.
So
You might be cooking. You're the gay one. Yeah, you actually might
is
be,
he?
yeah, you might be toasted.
Huh?
Maybe get reported.
I don't really care. No, why am I offensive? If you're for sure gay, why do I care? Why is that offensive anyway?
Maybe it might be true. I don't know.
Huh?
A micro? Did you say a micro?
You might be wrong.
No, I didn't know he. I don't. Well, we're live streaming, so.
Yeah. Oh yeah, Mr. I had a question.
I didn't know. I honestly thought he was.
If it actually
But there were some people brave. You know what I'm talking about. So there was one kid, like I think 2 years ago, I was helping this kid. So it was Kelly, and I told Kelly, I said this kid is gay, and Kelly got offended. Kelly says, "You cannot say that, Mr. Ye." I said, "Look, he talking like this. There's no way that he's not gay." Really?
Like that, yeah.
Actually no.
So really, that's the word.
You get a negative
No. Okay. So the funny thing is, so I went up to him. I said, "Are you gay?" And he's like, "Yeah, you know it. I'm proud of it." And he was like, and I was like, "See, Kelly, why is that offensive? That's nothing offensive. He's gay, and he doesn't mind." So why do you think that's offensive, though? That's my question. Why is that offensive?
People are very like everyone's like very open about it. Some people are more like sensitive to it.
Really?
Yeah, some kids are like, especially if they have like a family thing with it. Like most kids, if they have parental support, they're whatever. But yeah.
Mr. Ye, and we like ultra religious.
Oh yeah.
You don't share that. Also, there's a lot of people who are like very religious, but like they don't know they're gay. My brother's got a friend like that who's just like.
Really? Okay.
Everyone knows he's gay.
Well,
He doesn't know he's gay.
stand corrected, I guess.
No,
Dylan's right.
it's his roommate. But his family was like.
But there's nothing wrong being gay. I don't know why people get so offensive about it. What? Me too. I'm not gonna be offended. Anyway, I mean, I don't know. I think there's perspective in life. All right, so here's the thing. Last year I also posted this question. Last year, there was. Let's see. So there are situations that you can have multiple different asymptotes. So for example, I'm gonna give you this question. Let's say 3e to the x plus 5, and then it's 2 minus 4e to the x. Okay, so how many different asymptotes is here? How many different asymptotes?
Oh, we're doing asymptotes.
How many different asymptotes? Now this one's different. This one's a little bit different than other style. This question is a little bit more deeper. How many different asymptotes are there?
Yeah, okay.
Now this one doesn't work the same way as the other one.
I think it's just one. Just one.
There's no.
Listen, bro. Oh.
Am I three?
Because if you go to negative, you have
Yeah.
you have like
How many different asymptote this one has?
two. I want to get two. I only see one now.
Now what if it's like 3?
Oh, what's the third different? Oh shoot.
Oh, total?
I thought you were just talking about horizontal.
How many different asymptote there? And what are they? Right? So, first of all, how do you find a vertical asymptote? Denominator equal to 0. So, vertical asymptote, right? So, 2 minus 4 e to the x equal to 0. And negative 4 e to the x equal to negative 2. E to the x is equal to 1/2. And then natural log e to the x equal to natural log 1/2. X equal to natural log 1/2. Or negative natural log 2. So either one's acceptable. So this one or this one. So there's the first one. What's the other one? Well, horizontal asymptote. It's limit x approach to infinity of 3e to the x plus 5 over 2 minus 4e to the x. Now this one's slightly different because if you divide it by highest degree on the bottom, in this case, it would show like this. So limit x approach to infinity of 3 plus 5 over e to the x over 2 over e to the x minus 4. Now that's going to give you what? This one's going to give you negative 3/4, right? Now what's the other one? Limit as x approach to positive infinity, 3e to the x plus 5. Oh, sorry, negative infinity. 2 minus 4e to the negative infinity. It turns out you cannot divide it by that. It turns out that you have to think about other things, that e to the negative infinity is evaluable.
Students should now be back from A level.
So that's going to be 3 e to the negative infinity plus 5 over 2 minus 4 e to the negative infinity. So what's e to the negative infinity? 0. So it'll be 5 over 2. So there are 2 horizontal asymptote. Right, there was 2 horizontal asymptote and the 1 vertical. So I will ask a question like this, and you have to think about horizontal asymptote, vertical asymptote when e to approach into negative infinity, e to approach into positive infinity is a little bit different interactions. Does that make sense, Raphael? Any other questions? So your test is on Monday. Why? Okay, how about this one? What will be a horizontal asymptote and vertical asymptote here? How many are they? Two absolute value of x over 4x minus 1. How many horizontal asymptote are they? How many vertical asymptote are they? So how many situations you have two horizontal asymptotes? You have radicals, you have absolute value, and then you have e to the x.
Bro.
So Monday's test, you're gonna have to evaluate limit algebraically, not El Hopto rule. For now, we're gonna deal with El Hopto rule. By then, you're gonna hate El Hopto rule.
What?
Yeah, by then you're gonna have
What are you gonna do to help?
because we're gonna talk about 0 to the 0 power, and we're gonna talk about infinity minus infinity. We're gonna talk about 1 to the infinity power, and those you're gonna hate El Hopto rule.
Oh, we take derivative. Oh, yeah.
So right now we want just to do algebraically for now. And absolute value, right? Also one side limits, also limit x approaching infinity, horizontal asymptote, vertical asymptote. Rest of them is all math. You guys all have last year's tests. Good guidance.
Maybe. I just at the beginning of the year.
It's what? Somebody posted.
So, bro, everything's in focus.
Dude, there's no way. Last year's test. Dude, I had like analytics and stuff. Yeah, I'm not following it.
I might be able to.
Dude, I had 4 numbers last year.
So Ship, what is the vertical asymptote here? What is the horizontal asymptote here? 1/2 and what? No, negative 1/2. 1/2 and negative 1/2. Okay, that's it.
Was it the calculus review?
How do you find removable discontinuity?
It's whatever you cancel out when you factor.
Yeah. How do you find a non-removable discontinuity?
It's when the limits from both sides are not. Well, no.
It can be that way, but that's only
That's
happen with
all.
absolute value.
No, wait, no, it isn't.
It can be that way. That only happen with absolute value. Or it can be like a vertical asymptote when denominator go to 0. That's probably a primary one, but the jump discontinuity can happen with absolute value. So they can go like this. Like two things goes like this. Okay, that's it for test Monday.
Can you go recap?
No.